It had the torque. It had the promise. It had a name that made farmers believe, but it also had a secret. The Case 504 diesel engine was supposed to be the answer to a new era of farming. As the horsepower wars of the 1960s and 70s escalated, farmers weren't just looking for power, they needed it. Fields were getting larger, implements were growing heavier. Efficiency wasn't a luxury anymore, it was survival. Case engineers stepped forward with bold claims. The 504 would deliver the muscle to pull the heaviest loads, work the biggest fields, and outlast the competition. With a big displacement, a rugged design, and the promise of simplicity and strength, it looked like the diesel that could change everything. On paper, it looked like the future. The 504 wasn't just another diesel. It was marketed as a workhorse for the modern farm, a symbol of progress. It had the numbers. It had the torque, curve, and it had the Case name behind it. Farmers lined up, ready to put it to work. But soon the fields told a different story. It started small, engines running hotter than expected, fuel disappearing faster than planned, strange mechanical quirks. That didn't quite match the glossy sales brochures. Then came the breakdowns. Tractors stranded at the worst possible times, planting season, harvest season, when every hour lost meant dollars slipping away. Word spread. What was supposed to be a revolution in farming power began to feel like a mechanical betrayal. What went wrong? Was the Case 504 a victim of bad design? Was it pushed too hard by farmers demanding more than it could give? Or was it simply a machine built for a world that was changing too fast? In this video, we'll uncover the full story. We'll explore why the Case 504 was created, how it performed in real-world conditions, where it fell short, and why, despite its flaws, it still holds a place in the hearts of vintage tractor enthusiasts today. This is the truth about the Case 504 diesel, a farming disaster and a lesson for generations. By the early 1960s, farming was standing at the edge of a transformation. Tractors were no longer just simple machines for pulling implements. They were becoming powerful, sophisticated tools designed to handle the growing demands of modern agriculture. Farmers wanted more horsepower. Bigger implements meant deeper plowing, wider planting, and heavier loads. The race for power had begun, and every major manufacturer was under pressure to deliver engines that could handle it. Case, already a respected name in the agricultural world, saw an opportunity. They needed an engine that wasn't just competitive. They needed one that would lead. The result was the 504 diesel, a big displacement, high-torque engine designed to redefine what farmers could expect from their machines. The numbers looked promising. At 504 cubic inches, the engine offered the kind of raw muscle that farmers were craving. Case promised not just horsepower but usable power, torque at the low RPMs where tractors did their hardest work. Advertisements showcased its ability to pull the biggest implements through the toughest soil without breaking a sweat. The 504 was engineered for simplicity and durability. A straightforward inline six-cylinder design made it easier to maintain than more complex V8 setups. The hope was that farmers could service the engine themselves or rely on local mechanics without needing specialized tools or training. Case also emphasized fuel efficiency. At a time when fuel costs were starting to become a concern, the 504's designers claimed it would deliver more work per gallon than competing engines. For farmers trying to balance power with operating costs, that promise was hard to ignore. Early field reports were encouraging. Farmers who took delivery of 504-powered tractors praised the smooth power delivery and the ease with which the engines handled heavy loads. For a moment, it seemed like Case had not only met expectations but exceeded them. The 504 wasn't just an engine. It was Case's statement to the farming community. We hear you. We're building for your future. But as the horsepower race accelerated and tractors were pushed to their limits, the strengths of the 504 would soon be tested in ways no engineer could have fully anticipated. At the heart of the Case 504's promise was its engineering. When Case's team sat down to design this diesel, they weren't just trying to build a bigger engine. They wanted to engineer a better one. The 504 cubic inch displacement wasn't just a specification. It was a mission statement. Farmers needed engines that could deliver massive torque at low RPMs, where tractors spent most of their working lives. Horsepower numbers might impress on paper, but torque was what got the job done in the field. Case engineers chose a straight-six design favoring simplicity and strength over complexity. Inline six-cylinder engines are naturally balanced, reducing vibration and stress on the engine block and components. This natural balance meant longer life and fewer failures. Many competitors were experimenting with V8 and turbocharged configurations, but Case believed that farmers valued durability, serviceability, and predictability above all else. The engine block itself was a study in robustness. Thick castings were designed to absorb the punishing loads of heavy field work. The goal was clear: make an engine that didn't just survive, make one that thrived under constant stress. The fuel system was kept mechanically simple. Mechanical fuel injection delivered reliability even in dirty, dusty field conditions, and the early versions of the 504 avoided turbochargers, which some farmers still distrusted. The simplicity meant fewer points of failure and easier maintenance, an essential quality for farmers used to doing their own repairs. Case engineers also paid attention to fuel efficiency, a rising concern in the early 1970s as diesel prices edged upward. They claimed the 504 would deliver more work per gallon than competing engines, making it attractive not just for large farms, but also for smaller family operations where every dollar counted. The torque curve was another engineering focus. The 504 was designed to produce steady pulling power across a broad RPM range. This mattered because tractors rarely operated at a consistent speed in real-world conditions. Whether it was heavy clay, wet ground, or sloping terrain, the engine needed to adapt and keep pulling. Cooling capacity was also emphasized. Case integrated a heavy-duty cooling system designed to prevent the kind of overheating that plagued smaller engines when pushed too hard. For farmers working long days in hot, dusty fields, this was a major selling point. In early demonstrations and tests, the 504 engine seemed to live up to every promise. Reports from initial adopters praised its smooth startup, steady power delivery, and resilience under heavy loads. Unlike some engines that screamed or labored noisily, the 504 delivered a quiet, confident performance. Dealers proudly showcased the 504 at trade shows and plowing demonstrations. Sales brochures painted a picture of an engine ready to power a new era of farming. On paper and in controlled tests, Case had built what seemed to be the perfect farm diesel. But engineering never happens in a vacuum. Real-world fields aren't controlled environments. Mud, dust, operator habits, unpredictable loads. These variables could make or break even the best designs. The 504 had been engineered as a beast. But out in the wild, it would soon face challenges that no blueprint or bench test could fully prepare it for. At first, things went according to plan. Farmers who purchased Case tractors equipped with the new 504 diesel engine reported solid, early performance. The power was there. The pulling strength met expectations. For a while it seemed that Case had delivered on its bold promises. But as the work hours piled up and the tractors moved beyond carefully prepared demonstration fields into the unpredictable realities of American agriculture, the cracks began to show. The most common and most alarming problem was overheating. Despite the heavy-duty cooling system engineered into the 504, farmers reported engines running hotter than expected during extended periods of heavy work. Deep plowing, pulling large discs, or working on hot summer days pushed the temperature gauge into dangerous territory. In some cases, the overheating wasn't just an inconvenience. It led to cracked cylinder heads, blown gaskets, and, in the worst cases, complete engine failure. Then there was the issue of fuel consumption. While Case had promised good fuel efficiency compared to competitors, many farmers found the 504's appetite for diesel fuel to be much larger than advertised, especially under load. This was more than just a financial nuisance. Rising diesel prices in the 1970s meant that high fuel consumption could eat into already thin profit margins. Operators who expected a balance between power and efficiency were now making more frequent trips to the fuel tank and watching their expenses rise. But perhaps the most frustrating problem wasn't mechanical. It was operator expectations. The 504 was engineered to be durable and powerful, but many farmers treated it like previous generations of engines. They ran it hard. They lugged it at low RPMs. They pushed it into conditions that Case's test engineers may not have fully anticipated. Tractors aren't used in laboratories. They face mud, uneven terrain, heavy pulls, and long days. The same. Qualities that made the 504 powerful on paper, high torque at low RPM, simple mechanical systems, also made it vulnerable when operators pushed it beyond its comfort zone or skipped critical maintenance. Maintenance itself became an issue. While the 504 was designed to be serviced by farmers and local mechanics, not every owner followed best practices. Dirty air filters, infrequent oil changes, and neglect of the cooling system led to premature wear and breakdowns. In regions where dealer support was thin or parts supply was inconsistent, small problems often snowballed into expensive failures. Stories spread quickly. A neighbor's tractor overheating during planting season. An operator spending hundreds, or even thousands, repairing a 504 that was supposed to be bulletproof. Word of mouth, especially in rural communities, could make or break a product's reputation. By the late 1970s, that reputation was becoming mixed. Yes, the 504 had power. Yes, it could pull massive loads and handle tough jobs. But too many. Farmers had seen the downsides firsthand. The promise of the 504 was giving way to the harsh reality of farming's unpredictability. For every farmer who praised the engine's muscle, another shared a story of unexpected failure or high operating costs. The Case 504 had entered the field with high hopes. Now it was facing something much tougher than engineering challenges. It was facing the judgment of the farmers who relied on it. By the late 1970s, the Case 504 was no longer just an engine. It was a case study in engineering compromise. To truly understand why it struggled, you had to look beyond simple breakdowns and dig into the deeper mechanical and human factors that shaped its fate. First, the cooling system, while designed to handle heavy workloads, wasn't always enough in extreme conditions. Farming in the Midwest heat, deep tilling, and sustained low-speed operations pushed the engine beyond what the factory had anticipated. Many farmers unintentionally ran the engines hot by operating at lower RPMs, expecting the 504 to behave like older, low-speed diesels. But the 504 wasn't designed for low-speed lugging. It thrived at moderate RPMs, where airflow and coolant circulation were optimal. When lugged down, the engine couldn't dissipate heat fast enough, leading to thermal stress, cracked heads, and gasket failures. Then there was fuel delivery. The Eisaber mechanical injection system, while simple and reliable on paper, required precise tuning to maintain efficiency and prevent overfueling. Without regular adjustments, which many owners neglected or didn't know how to perform, the engine either ran too lean, causing power loss, or too rich, wasting fuel and accelerating wear. Airflow presented another hidden challenge. Dirty. Restricted air filters choked the engine, further compounding overheating issues and reducing combustion efficiency. In dusty farm environments, even well-meaning operators sometimes failed to clean or replace filters often enough. The engine block's design, while robust, had another unintended consequence. Its thick casting helped durability, but also trapped heat during prolonged heavy work. This became especially problematic for operators who upgraded implements and asked the 504 to pull loads heavier than its original design specs. But perhaps the most significant flaw wasn't mechanical at all. It was misaligned expectations. The Case 504 was marketed as a bulletproof workhorse. Farmers expected it to handle any job, in any condition, without the need for specialized care. And when early sales brochures touted its simplicity and power, few buyers imagined it would require careful RPM management, precise maintenance, and an understanding of its mechanical limits. Compounding the issue was dealer support. While Case, dealerships generally had good mechanics, the surge in demand for high-horsepower tractors outpaced the training and supply chains needed to support advanced engine designs like the 504. In some regions, parts delays and limited service experience left frustrated owners to troubleshoot serious problems on their own. As negative stories spread, overheating, fuel thirst, maintenance headaches, the 504's reputation became a mix of respect and resentment. To some, it was still a marvel of engineering strength. To others, it was a cautionary tale about trusting too much in raw horsepower without considering how real-world farming would test that power. The Case 504 didn't fail because it was a bad design. On the contrary, it had strengths that, under the right conditions, made it a solid performer. But farming rarely offers perfect conditions. The flaws came from a mismatch between the demands placed on the engine and the design limits baked into it. The gap between laboratory expectations and field reality proved wider than anyone, including Case engineers, had predicted. In the end, the 504 became both a lesson and a legacy, a reminder that power alone can't guarantee success, especially when working with the unpredictable challenges of farming. The Case 504 diesel was never supposed to become a cautionary tale. It was engineered to be a workhorse, a reliable partner for farmers trying to do more with less, and in many ways it succeeded. Under the right conditions, with proper maintenance, reasonable loads, and operators who understood its needs, the 504 delivered seasons of dependable service. But farming is rarely about ideal conditions. It's about mud, heat, long hours, and unpredictable demands. In that harsh reality, the weaknesses of the 504, overheating, fuel consumption, and maintenance sensitivity, couldn't be ignored. For some, the 504 became a source of frustration. Repairs were costly. Downtime during planting or harvest could turn a profitable year into a financial headache. Word spread. Stories of cracked heads, blown gaskets, and relentless fuel bills created a reputation that Case struggled to shake. Yet for others, the 504 became a badge of resilience. Farmers who understood the engine's quirks and treated it with care found it could deliver serious muscle season after season. Collectors today still seek out Case 504-powered tractors, not just for nostalgia, but for the raw power and mechanical simplicity they represent. More importantly, the Case 504 left a deeper legacy. It taught equipment manufacturers and farmers alike that power isn't everything. Design needs to account for the unpredictable, for human habits, for the realities of working machines hard in less than perfect conditions. The lessons learned from the 504's successes and failures influenced future designs, not just at Case but across the agricultural equipment industry. Engineers began to prioritize not only horsepower but also cooling capacity, fuel efficiency, operator error tolerance, and serviceability. The Case 504 wasn't a failure, it was a turning point. A moment when farming's demand for bigger, faster, and stronger collided with the real-world limits of engineering and economics. Today, when you see a restored Case 504-powered tractor at a vintage show or hear one roar to life at a tractor pull, you're not just witnessing a piece of machinery, you're witnessing a piece of farming history, and a reminder that even the most powerful machines carry lessons that endure far beyond their time in the field. If you enjoyed this deep dive into farming history, don't forget to like this video and subscribe for more stories from the world of agricultural engineering and the machines that shaped it.